I'm just going to show you how I built this, explain it a tiny bit. There's not much to explain. It's a very simple unit, but it's very scalable. This power supply is way too big for these units, obviously. Let me know what you think. Like, comment, and subscribe if you want to see more of this stuff. If you're into building 18650 off-grid solutions using lithium batteries. It's model 300 TAC 24. It's a 12.5 amp power supply that can do between 0.3 volts and 28.7 volts. I got it a long time ago, so I added this. I used my Dremel and I cut a slot in there. Link in the description to buy this part off Banggood. So I coated it in liquid tape. This stuff. It's like 10 bucks, 15 bucks for that stuff. I just have wires snaking through, and then I took these screws off completely, and then I drilled holes through the plastic down there, if you can see. So I just drilled down in there and then shoved through, so that way it's minimalistic. Then I also drilled holes for these two potentiometers and removed the stupid tiny ones. These ones came with it, ones like this, and they're garbage. So instead I put these on, and I don't know if one of them works or not. I don't think it does, but I have no interest in troubleshooting it since this unit will just run these guys up here, right? So yeah, and I had to put the fan on the outside of the case because this guy is up too high and I would hit the fan. This is fine though, this lip here. I finished building this device. It was a little tricky mounting these guys, but as you can see it's pretty seamless. And holes drilled just perfectly, so everything just kind of drops down and disappears down into the floor, even that wire there. And then I also have an on-off switch for this fan, very small one. I guess I could paint it black, but I mean, with the brackets are pretty ugly. They're just pieces of metal that I had lying around. In the back here is very minimalistic. You know, everything's tucked in behind. This is the only wire that doesn't do that because I just felt like there was no point in making it go down and then back up. Plus I wouldn't have been able to put this back bar on. Putting in the voltmeter, having this, also having this. So the wires are in there and then they run all the way into the back here. You can just barely see them hidden under there. On the back side, so it's pretty straightforward. I wanted lots of extra wire just in case. It doesn't harm anything to have some extra wire. And nothing really to say. I used a grinder to just nip off the screws, so I screwed all the way through so it was sticking out, and then I just zip cut it off and then grind it down smooth. And I found that that's the best way to put screws into wood, especially wood this fragile and thin, is you just use really long screws and then you cut them off. And that's going to be your best bet. So pretty straightforward. I put these on just where the screw goes. They're on there, and then I can put this on the wall so it's up out of the way. I made it so that there was all this room here so I could put batteries right there. It'd be kind of convenient, right? You could stack quite a few batteries just right up here while you're charging the rest of them. I'm plugged in now, so you can see it reads 14. Well, I can crank it down to 12. These units seem to survive quite well on very random amounts of power, but I don't feel like testing that. The fan is running, so I can turn it off. No issue. I could have put an amp meter in here as well, but I felt like I was way over budget. Like, I have devices over here, but they're very big, bulky, and I felt like it was just a lot more work than what it was worth. I don't really need to know the amp draw of these units. I had to put this one backwards. You probably wondered why, and this is why, right? Positive, right? 3% difference. That's the difference between patents and copyright laws. That's why they did that. 3%. Just flip the batteries around. So it makes it very inconvenient. One strength that the LIIs have is they do the internal resistance test right away. Right? So they tell you right away. Whereas the BT, you have to do a quick test, which I feel is very inconvenient. So anyways, yeah, that's it. It's done and built, and the fan does a great job of pushing the air and cooling down where these, I assume, MOSFETs are. And this unit works great. The fan only turns on when it has to, when I crank it up, but, you know, I can't complain about any of this. How I mounted these guys, it was very, very difficult. BTC 3400, I mounted it by drilling holes where the screw heads are. There's 4 holes there. The screws are there. Okay, there's a little bit, so I had to take off the back plate, unscrew it, take this unit off. Then I screwed 2 small screws, these kind here. I screwed them in so the back plate was screwed onto the wood, and with these holes drilled, I had access to the screws, so then I could put this back down and then put the screws back into it to hold it into place. It was a lot of messing around, but the results are there's no brackets. Otherwise I would have had to have used zip ties or metal brackets, pinching it down. I don't have any of that. It's very secure with just 2 screw heads and to the back plate. With these guys it wasn't as bad, but I pretty much had to do the same. What I did first is I used a drill bit and I just carefully went right down through, and I pushed the drill bit through, down, and then it also made the hole through the wood as well. And then I took the plate off, the charger off, and screwed it. They have 6 screws instead of 4, so I take off all 6 screws for the back plate, pop it off. I then have the plate on its own. I put the 2 screws, these ones, into it right here and right there. And these are very small screw heads. That's where the important part comes in. Okay, so then once those 2 screws are all the way in, then I put this thing back together, then I put it down on here, and then I can fit my bit. I can fit it down in there, and then slowly, a little bit, like I had to keep going back and forth, and I slowly, you know, tightened it down onto this wooden back plate. Right? It's very thin wood. It's some scrap wood I had lying around. Everything is always scrap that I have lying around. I do not want to spend any more than I have to on this. It's a lot of messing around, but like I said, it's secure. And there's no ugly metal brackets anywhere. I wish these guys, like, hindsight's 2020. What I could have done is drilled in the back plate of all of these. I could have drilled a big hole and then a small slotted hole so that I could make my own holders, like, so that you could put it down and then slide it into, you know, screws that you had set up. I could have done that, but it wouldn't have been as secure as this, because these will never move anywhere. They'll never come off. But not a big deal. I just thought you might find this interesting. It's a good little charger. It's I like that I can hang it on the wall, and there won't be any issues with it. But yeah, so that's how I built mine. And of course this is scalable, right? Like this power supply is like a 300 watt power supply. That consumes 3 amps at 12 volts. So you can do the math pretty quick on that. And yeah, I've owned this power supply forever. And I had to resolder the back plate of this because it all went cold joint on me. So I had to resolder every single contact point, especially these DC side. There was so little solder on the back plate here, it's ridiculous. So I had to redo that and then put on these potentiometers because those small ones, they're terrible garbage, and then putting this guy on. Fan is the most important thing in my opinion, trying to keep these cool. So I hope you like this little build. I thought I'd make it its own video. Let me know what you think about it. You know, like, comment, subscribe, and have a great day, guys. Bye.
We're on a bridge.
Pretty neat, eh?
It's pretty scary. There's a sea monster in there. I can see it. His eyes are looking at me. Yeah.